Hello guys, for today's asynchronous session day, you are going to be watching me go over the Unit 1 review problems. You may have done these on your own or you may have not. However, I highly encourage you to watch this video to figure out how to solve the various questions that you would see in your Unit 1 exam, which is tomorrow. The first question asks, which undefined geometric term describes an infinite set of points that has length but not width? Well, we have various undefined geometric terms in this question. However, we know that a sphere is not an undefined geometric term. Let us remember that the undefined geometric terms that we learned about are point, line, plane, and distance. So, we can automatically cross off sphere. Let's look at the first term, distance. We haven't quite gone over distance in Unit 1, so we could ideally just cross that one out. We will review distance until Unit 2. Now line. We learned that a line is in fact an infinite set of points which make up that line. Lines have length but do not have width. This figure is asking us which figure represents an undefined term. Well, like I said before, we did learn about various undefined terms in this class. So far, we have learned about line, point, and plane. Therefore, we are looking for a diagram that represents either a line, point, or plane. Let's look at the first one. In this instance, we can quickly identify that A is not our answer. Why? Well, because it has one endpoint and a line that extends infinitely in the other direction, making this a ray. A ray is not an undefined term that we have identified. Therefore, this is not our answer. Let's look at the next diagram. This diagram contains two endpoints. Well, this is what we know as a segment. Let us remember that a segment is not an undefined term. Let's look at the next one. Here we see what is known as an angle. We know this is an angle because we have two rays that meet at a common endpoint, making this an angle. Angles are not undefined terms, therefore, we know that this is not our answer. In this instance, we do in fact have a line. How do we know it's a line? Well, because we know that lines extend infinitely in either direction. Therefore, it is reasonable to assume that D is our answer. Let's go to the next question. This question asks, what statement regarding undefinable terms in geometry are true? We're looking for true statements regarding undefinable terms in geometry. We are to select two options. Therefore, because we know we are to select two options, we know that if we select three options, well, then one of those must be wrong. So we are looking for true statements regarding undefinable terms in geometry. Let us see. The first one says that a point's location on the coordinate plane is identified by an ordered pair x and y. Well, we know that a point does in fact represent a location in space. We know that points can in fact appear on coordinate planes, and we do in fact know that the ordered pair is x dot y. The next statement states that a point has one dimension length. Well, we just reviewed that in the previous problem, but we can also determine that this question or this statement is incorrect because a point is zero-dimensional, which means it does not have length. Let's look at the next one. This states that a line has length and width. Well, we have identified in the previous question that a line only has length and does not have width. So we know that that is not a true term. That being said, we can automatically determine that this is our correct answer, but let's look at it. A distance along the line must have no beginning or end. Well, what do we know about lines? We know that lines, in fact, do not have a beginning or end, and in fact extend infinitely in either directions, making that statement true. This part is part of that question, so let us just review it. It states that a plane consists of an infinite set of points. Well, we actually know that a plane consists of an infinite set of lines, while a line consists of an infinite set of points. We did review this in the previous problem, and basically a plane is composed of an infinite set of lines looking very much like this. Therefore, it's reasonable to assume that that statement is not true. As you can see, we have selected two true statements regarding undefinable terms in geometry. Let's look at the next problem. This problem states the points J and K in plane H. Well, we see here that points J and K are in fact in plane H. We are asked how many lines can be drawn through point J and K. Well, we know that through any 2 points, we can draw one and only one line. Therefore, our answer would be 1. I will say that again. Through any 2 points, we can draw one and only one line. In this case, this line would look like JK and could be symbolized as either JK or K and J. Wonderful. Let's move on. Now we're getting into defining terms. This is lesson 2 of unit 1. Let's look at the first question. This asks, which figure can be precisely defined by using only undefined terms? Select 3 options. Well, we have identified various different definable terms in geometry. However, we have not specifically gone over arc, so we can exit that out. We are being asked which figure can be decisively defined using only undefined terms. Well, we learned that an angle actually uses a definable term in its definition. Let us remember that an angle was defined as 2 rays which share a common endpoint. Rays is a definable term, which means that that definition does not contain only undefinable terms. Let us remember once again that our undefinable terms are point, line, and plane. Therefore, it's reasonable to conclude that angle is also not the answer. We are being asked to select 3 options. In this instance, we are left with those 3 options. However, let's review this. We know that a circle is defined as a center point being equidistant from all other points in a given plane. In this instance, we use the definable terms point and plane. Let's look at line segment. We learned that line segments is a part of a line that contains 2 endpoints. Well, That means that line segment contains the undefinable term line. We also learned that parallel lines are two lines that never intersect. Again, we are using the undefinable term line. Therefore, it's reasonable to conclude that circle, line segment, and parallel lines are three definable terms that only use undefinable terms in their definitions. Let's look at the next question. This question is asking us what line is shown in the figure. Well, we know that lines contain two arrows indicating that those lines extend infinitely in either direction. We can see here that there are in fact various segments in this diagram, but there are only one line. How do we know that these are segments? Well, because they contain two endpoints and do not extend infinitely in either direction. Therefore, it is reasonable to conclude that the only line that we see in this diagram is in fact line XZ or line ZX. So we are looking for the answer choice that either states line XZ or line ZX. Why can it be either line XZ or line ZX? Well, because we can start with either point. Therefore, it is reasonable to conclude that this is our answer. Let's look at the next question. This question is asking us which rays are a part of line BE. Well, let's first identify line BE. Now, let's think about rays. We know that rays have one endpoint and continue infinitely in another direction. Rays can take either direction, but in every case, rays have one endpoint and extend infinitely in another direction. So, now that we know what line BE is, let's identify the rays. Well, we have one ray here, and that is ray AB. Remember that we name rays starting with the endpoint first, and in this case, the endpoint is endpoint A. And then we have ray AE. Again, starting with the endpoint first. So, we are looking for the answer choice that includes both ray AB and ray AE. Here we say AE, but we do not see EB, so we can cross that out. Here we say ray AB and ray AE. We have identified our answer choice. But let's look at the other answer choices. Here we have ray AB, but we do not have AE. Here we have AB, but again we do not have AE. Therefore, we can cross out both those answer choices. Let's move on to the next question. This is asking us, what is the definition of a ray? Well, like we said before, a ray has one endpoint and continues infinitely in the other direction. Let's look at our different definitions. A part of a line that has one endpoint and extends indefinitely in one direction. So let's look at this question. This question is stating which defined term uses the undefined terms point line. Well, here we have different defined terms. We know that angles are defined by two rays sharing a common endpoint. Well, we know that this uses the word point, which is an undefined term, but instead of using the word line, it uses the word rays. Rays is not an undefined term, therefore we can cross that out. Let's look at the next term. We know that a circle is a plane that contains a center point, which are equidistance from the other points. Here we see the term ray, and we see the term points, but we do not see the undefined term lines, therefore we can cross that out. Let's look at the definition of parallel lines. Parallel lines are two lines that never intersect. Here, we do see the undefined term lines, but we do not see the undefined term points. Therefore, we can cross that out. Through process of elimination, we can see that the term ray does in fact use the undefined terms point and line. Let's look at this. A ray is defined as a part of a line that contains one endpoint and extends infinitely in one direction. This is the definition of a ray. In this definition, we do see the undefined term line, and we do see the undefined term point. Therefore, it's reasonable to conclude that ray is the defined term that uses the undefined terms point and line. Let's get into measuring lengths and angles. This says, given the EB bisect of CEA, angle CEA, what statement must be true? We must select three options. Well, what we are looking at is we are looking at this angle CEA, and we are looking at its bisect BE. Let's look at the different statements to determine which of these is true. From this diagram, we want to see if it's reasonable to assume that CEA is equal to 90 degrees. Well, we can in fact determine this from this diagram because of this orange box. This orange box indicates to us that the angle measure of CEA is in fact 90 degrees. Therefore, we can select that answer choice. Let's look at the next one. This is stating that measure CEF is equal to CEA plus BEF. Well, here's CEF. The angle measure of CEF is this entire angle. We know that straight lines are equal to 180 degrees. Therefore, what we're trying to identify is if from these two angles, we can get 180 degrees. Well, let's look at those other two angles. The first angle is CEA. And the second angle is BEF. Well, it looks like BEF overlaps angle CEA, which means that if we added CEA and BEF, we would not get to 180 degrees. In fact, we would get over 180 degrees. In order to calculate 180 degrees, we could either add this angle plus this angle plus this angle, Or we could add this angle plus this angle. That is not in this option. So that is not a true statement. Let's look at the next statement. The next statement states that the CEB is half that of CEA. Well, what we know about bisects, which is BE, is that bisects actually cut angles in half. So in this instance, that bisect BE is cutting the angle CEA in half. Therefore, it is reasonable to assume that the entire measure of CEA is equal to 2 times the angle measure of BEC. Or CEA is equal to the angle measure of BEA. However, in this instance, this statement is telling us that the entire measure of CEB is 2 times that of CEA. That is incorrect. In fact, what we are looking for here is that the angle measure of CEB is half that of the entire angle measure of CEA. Therefore, we cannot reasonably assume that that statement is true. Let's look at the next statement. CEF is a straight angle. Well, it is in fact a straight angle. How do we know that? Well, because it's reasonable to assume that this angle measures to 90 degrees from that box that we see there. Therefore, given that these two angles, angle CEA and angle AEF, are linear pairs, it is reasonable to assume the angle AEF is also 90 degrees. Therefore, it is reasonable to assume that the measure of angle AEF is in fact 180 degrees. Let's look at the last. As we can see here, I just identified that angle CEA is a linear pair to angle AEF. Linear pairs are two adjacent angles whose measures equal a sum of 180 degrees. Therefore, because we know that the angle measure of CEA is 90 degrees, it is reasonable to assume that 180 minus 90 degrees is equal to 90 degrees, which means that it's reasonable to assume that the angle measure of CEF or AEF is in fact 90 degrees. Therefore, we can select that answer choice. Let's move on to the next question. This question is telling us that CE is the angle bisect of ACE. So CE is the angle bisect of ACD. We are trying to see which of these statements about the figure must be true given that information. Well, let's look at the first statement. The first statement is saying that ECD is 1/2 the measure of ECB. Well, we know that CE is the angle bisector for angle ACD, but we do not know that CE is the angle bisect of angle ECB. Therefore, it's not reasonable to assume that that line or that ray that bisects that angle necessarily bisects ECB. Therefore, it's not reasonable to assume that that bisect cuts that angle in half. Therefore, we cannot conclude that answer. Let's look at the next statement. This statement states that ACE is 1/2 the measure of ACD. Well, because we know that CE bisects the angle ACD, it is reasonable to assume that these two angles are congruent. Remember that bisects cut an angle directly in half. Therefore, it is reasonable to assume that the angle ACE is 1/2 that of the entire angle ACD. Therefore, that is our answer choice. Let us remember that angle bisectors cut angles in half. Angle bisectors cut angles in half, thereby making those two angles congruent. Let's look at the next problem. This is stating that FG is 2 units, FI is 7 units, and HI is 1 unit. So we're asking, what is CH? Well, we know that the entire D of that measure of that line segment is equal to 7 degrees, right? So the entire line segment is equal to 7 degrees. That is line segment FI. Well, in order to find the measure of GH, which is this line segment, we would take what we are given and subtract that from 7. So we know the FG is equal to 2 degrees. And we know that HI is equal to 1 degree. What we do not yet know and what we're trying to identify is what the length of the line segment GH is. So that is our X in this instance. Well, in this information, we can combine like terms. So that takes us to 3x equals to 7. Well, then we can subtract 3 from each side, given what we learned in algebra, and we get to x is equal to 4 units. Oops, sorry guys. X is equal to 4 units. Let us remember that x was equivalent to the length of line segment GH, so it's reasonable to assume that GH is equal to 4 degrees. Let's look at the next problem. This problem states that point G lies between F and H on line segment F and H. So point G lies between those two segments. So we are being told here that the length of F and H is 18, which means that we've been told that the entire length of this segment F and H is equal to 18 units. Given that information, we want to find the value of x. So we are given, and what we know from the segment addition postulate is that if we add FG plus GH, we can solve for the entire measure of f and h. Well, we have already been given that f and h is equal to 18, g and h is equal to 2x, and f and g is equal to 4x. Therefore, the next thing we would do is combine like terms, which gives us 6x equals 18. We would divide 6 by both sides, and we would get that x is equal to 3. Once again, we are looking for the value of x, which is 3. Let's look at that. Now we're going to review this next question. This next question tells us that angle PSR measures 99 degrees. Here's angle PSR. That entire angle is equal to 99 degrees. We're being asked to identify what is the measure of angle PSQ. PSQ can be identified as this angle right here. Well, that being said, we can use what we know about the angle addition postulate to solve for PSQ. So we know the measure of angle PSR, right? According to the angle addition postulate, we can use that information to find the angle of PSQ. In order to do that, we would add angle PSQ to angle SQR to find the entirety of that angle. That is the entire angle of PSQ. So we are looking for the angle measure of PSQ, but we are given PSR. According to the angle addition postulate, we can add these two angles together in order to find the entirety of that angle, right? So let's see what we are given. Well, we are given that PSR is equal to 99 degrees. We are given that PSQ is equal to 3x plus 18. And we are given that SQR is equal to 9x minus 27. Well, what we can do is take what we learned from algebra and combine like terms. So, if we combine like terms, we can identify that 3x plus 9x is equal to 12x. 18 minus 27 is equal to negative 9, which gives us 99. Now, we would take the 9 and add it on each side, which gives us 108. So 108 equals 12x. Well, in order to isolate the x, we also have to divide by 12 on each side, which gives us x equals 9. Well, now that we know that x equals 9, we can substitute that into what we have been given for PSQ to find the exact angle measure in degrees of PSQ. So basically what we would do is take 3x plus 18, substitute 9 for x, and that would give us 27 plus 18, which equals to 45 degrees. So that tells us that angle PSQ, that is that angle right here that we are looking for, is equal to 45 degrees. So that is our answer. Okay, let's move on to the next problem. So we are looking at what happens when two lines intersect at a right angle. Well, two lines intersecting at a right angle means that we have two lines that intersect at one point, and that is at a right angle, which means a 90-degree angle. Well, do those two lines form a line? Well, no, because we already have two lines, so we can exit out that answer choice. Are those two lines parallel? Well, parallel lines actually look like two lines that never intersect. Therefore, the fact that they do intersect tells us that they are not parallel lines. Are these perpendicular? Two lines intersecting at a right angle is exactly the definition of perpendicular lines. Those two lines intersect at a 90-degree angle. Form a ray? They do not form a ray because they are just two lines intersecting. Let's go to the next problem. This problem is asking us, what is the distance between A and B? Well, the first thing I would do is to answer that question is to identify what the space between each number line represents. So, it appears as though we are going by ones. Plus 1, plus 1, plus 1, plus 1. Because we are going by ones, the easiest way to solve this problem is to simply skip each tick mark and to identify what the length between A and B is. So you would go 1, 2, 3, 4, 5, 6. The reason that this is the easiest way to solve this problem is because each tick mark is in fact going by 1. If each tick mark was not going by 1, well then you would have to use what we learned about the line segments, and we would solve for the absolute value and the difference between those two numbers. But in this instance, all we have to do is count each tick mark, identify that from A to B, it is 6 units. Let's look at the next problem. Now we're getting to conditional statements and equivalents. Let's look at the first problem. This problem is asking us to identify the inverse of the conditional statement. This is our conditional statement. That is being told to us, but we can clarify or verify that it's a conditional statement because it contains an if and then, right? Conditional statements can take the form if, dot, dot, then, dot, dot. The inverse of a conditional statement, as we learned before, means that we simply keep the hypothesis and conclusion the way they are, but we negate it. So we would just simply add in not. So let's look at the answer choices to see what follows that model. If a polygon, well, we do not see not, so we can exit that out. If a polygon is not a pentagon, well, we can exit that out. Why? Because we here see that the conclusion has been changed around, which is what we are not looking for. If a polygon does not have 5 angles, then it is not a pentagon. That is exactly what we are looking for. Let us remember that the conditional told us that if a polygon does have 5 angles, then it is a pentagon. This is telling us if that polygon does not have 5 angles, then it is not a pentagon. Therefore, our answer choice is C. Let's look at the next problem. This problem is telling us that the original conditional statement is represented as P, Q. What represents the converse? Well, because the conditional statement takes the form P/Q in symbolic form, we know that converse statements switch the hypothesis to the conclusion around, right? They switch the hypothesis and conclusion around. Well, all we would simply have to do is also switch the hypothesis and conclusion around in this symbolic form. And so we are looking for that which represents Q then P. Here's Q then P. Therefore, that is our answer. Look at the next question. The next question is asking us to read the statement. Doubling the dimensions of a rectangle increases the area by a factor of 4. If P represents doubling the dimensions of a rectangle and Q represents the area increasing by a factor of 4, what is true? Well, this is basically telling us that if P represents our hypothesis and Q represents our conclusion, well then which of these is true? P/Q represents the original conditional statement. Well, that is correct. Why? Well, because we have if P and then Q, right? Next question. Not P, not Q represents the inverse of the original conditional statement. Remember, the inverse keeps those two, the hypothesis and conclusion, the way they are, but simply negates them, so that is true. Well, we have already selected two options, but let's look at the other options just to be sure. This is saying that Q and P represent the original conditional statement. Well, we know that conditional statements follow the form P then Q, right? So in this instance, Q then P would actually not be the original conditional statement. It would instead be the converse of that conditional statement. Let's look at the next one. If not Q, then not P represents the converse of the original conditional statement. Well, I just showed you that it actually is if Q then P that represents the converse of the original conditional statement. Let's look at the next problem. P, if and then not Q, represents the contrapositive of the conditional statement. Well, if we know that this is our conditional statement, we know that in order to find the converse, you have to switch the hypothesis conclusion around and then negate them. So in order for it to be a contrapositive, it would have to follow these symbols. As you can see here, let's look at the next question. This is stating that P is angles X, Y, Z, and RST are vertical angles, and Q is stating that angles X, Y, Z, and RST are congruent. Well, we are looking for what is logically equivalent to this conditional P if Q. Well, we know that the contrapositive is logically equivalent to the conditional. This is our conditional, if P then Q. So we're looking for the contrapositive. Well, let us remember that the contrapositive switches the hypothesis to the conclusion around and then negates them. So we are looking for the statement that basically states if not Q, then not P. Let's see. Well, first thing to do, we are looking for the keywords not. Here we don't see any knots. Here we see a knot. 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 Here we see a knot, and here we don't. The easiest way to take on this question is to eliminate all those that do not contain the negation on both the hypothesis and the conclusion, or on both P and Q. So now that we have eliminated those two answer choices, we have to identify which answer choice says not Q, then not P. Well, here we see if angle XYZ and RST are vertical angles? Well, that was our P. So this is saying if not P. Immediately, we can eliminate the answer because the first thing that we need to get to is if not Q. Let's look at the next statement. If angles X, Y, and Z and RST are congruent, well, that is our Q. So here we got if not Q. Let's double check to make sure on the second part we get then not P. Then they are not vertical angles. Vertical angles was our P. So in this instance, we have if not Q, then not P. And that is what is logically equivalent to the original conditional statement. Let's look at the next part of our lesson. Now we're going to get into compound statements. Let us see. So we see here that we are trying to identify which statement represents P and Q. Let us remember that this symbol represents a conjunction. Conjunctions use the word and to connect two statements together. Oops, sorry. So in this instance, we are trying to find which statement represents P and Q. Well, the easiest way to go about this question is to first identify which of these uses the word and. Well, in this instance, we can see that only one statement uses the word and therefore we can logically assume that that is our conjunction because conjunctions use the word and. However, to double check this, let us make sure that it goes in the form P and Q. Well, here we know that P says that number is even. The number is even. So we have P and we have Q. Number is prime. Number is prime. So here we can see that we have P and Q. Let's look at the next. Let us look at this next problem. This problem is different from any other problem that we've seen so far, but it's very easy. Let me show you. Here we are given that P represents the shape as a rhombus. Q represents that the diagonals are perpendicular, and R represents that the sides are congruent. Well, we are being asked to identify which of these represents the following statement. This statement states that the shape is a rhombus if and only if the diagonals are perpendicular and the shapes are congruent. Well, how did we get here? Well, we saw the shape is a rhombus, which we saw here was P. We saw if and only if, which we know is a biconditional. We saw diagonals are perpendicular. We saw and, which we know is a conjunction. And we saw the sides are congruent, which is our R. Therefore, we can reasonably assume that C is our answer. Why is that? Well, because C matches. Let us look at the next question. Here we see that P represents a student who plays basketball, and Q represents a student who plays tennis. Well, we are being asked to solve how many students play both basketball and tennis. Well, the easiest thing to do is to first label each one. So P represents basketball, P represents basketball, and Q represents tennis. Well, given this information, we are trying to find how many students play both basketball and tennis. Well, that is this middle section. Therefore, we can identify that 4 people play both basketball and tennis, making A our answer. We are going to disregard the last questions, as you will not see these types of truth tables on your Unit 1 exam to prove. Here we see a 2-column proof. We know that this proof is 2 columns because it contains a statements column and a reasons column, making it a 2-column proof. This question is asking us to identify what is the missing reason in step 3. Here is step 3. It states that the measure of TRS plus the measure of TRV equals 180 degrees. Well, let's identify TRS and TRV. What can we conclude about those 2 angles? Well, we can actually conclude that if those 2 angles are equal to 180 degrees, like is stated here, well then those 2 are linear pairs. So, if we know that those 2 are linear pairs, we can identify that if we add 60 plus 4x equals 180, then that is what we are being asked or told to do in reason 3. This is actually part of the angle addition postulate, which tells us that if we know the total measure of 2 adjacent angles, then we can add those 2 angles together to find that total measure. Let's move on to the next question. Here again, we see a 2-column proof. We know that this is 2 columns because we have a statements column and a reason column. Here we are being asked once again to find what is the missing reason in the proof. Well, here we see that we are being told that ABC is congruent to ABD. This symbol represents congruence. Given that, it is reasonable to assume that this represents the definition of congruent angles. This is telling us that those 2 angles are congruent, leading us into the definition of congruent angles. Let's look at the next question. What is a flowchart proof? That is what we're being asked. Well, we know that a flowchart proof takes a form that looks like this. One second. It looks like a flowchart. And we know that we start with what we are given and we end with what we are trying to prove. So let's look at which of these statements represents what we know about flowchart proofs. The first one states that a flowchart proof contains a set of sentences explaining the given steps needed to reach a conclusion. Well, this actually sounds more like a paragraph proof, but let's look at the other examples. Uses inductive reasoning to prove a statement. Well, we learned that proofs actually use deductive reasoning to prove statements. So we can exit that one out. Let's look at the next one. A visual representation, A visual representation of the logical flow of steps needed to reach a conclusion. Well, here we have our logical flow of steps in a visual kind of representation. So it's reasonable to assume that that is our answer. I would say that this is a paragraph proof and is a better definition of such. While the last one, which states, contains a table with a logical series of statements and reasons that reach conclusion, is actually a great definition for 2-column proofs. Let's look at the next answer. or the next question. Now we're going to get into linear pairs and vertical angles. Let's look at the first question. In which diagram does angle 1 and angle 2 form a linear pair? Well, we know that linear pairs are two adjacent angles that share a line. They share a line, and each of those angles contains opposite rays which face opposite directions, and that's what is known as a linear pair. Here we have two adjacent angles that share a line, making them a linear pair. Well, it's reasonable to assume that the diagram that matches this most closely is, in fact, diagram D. As you can see here, you have angle 1 and 2 that share that common line, making those linear pairs. Let's look at the next statement. Here we are asked, in the diagram, what is the measure of VSR? So here we have VSR. So we are looking for the measure of VSR. Well, a unique thing about this diagram is that we can actually identify a linear pair. And that is angle VSR with angle VSU. Angle VSR and angle VSU are linear pairs. Well, given what we know about linear pairs, if you add angle VSR plus angle VSU, you would actually get 180 degrees. So, given that information, we are looking for the measure of VSR. Well, we have already been given the measure of VSU, which is 100 degrees, so we could substitute that in. In order to find the measure of the missing angle, we would subtract 100 from each side. And we would actually get that VSR is equal to 80 degrees. Now let's look at our next question. In this question, we are being asked to solve for the measure of WRS. Here is WRS. We are not currently given any information about WRS. However, we are given information about the angle VRT. What do we know about VRT in relation to WRS? Well, we actually know that those two angles are vertical angles. And what do we know about vertical angles? Well, we know that vertical angles are congruent. If we solve for the angle of VRT, well then we also solve for the angle of WRS. How would we do that? Well, let's see what other information we are given. We are actually given information that VRS is a linear pair, because they share the same line, to angle TRS. What did we just review about linear pairs? Well, if you add those two adjacent angles together, you would get 180 degrees. Given that information, we would combine like terms. Which is 30x plus 30 equals 180. We would subtract 30 for both sides. We get 30x is equal to 150. 150 divided by 30 equals x equals 5. So we have been given that x equals 5. Oops. What does that tell us? Well, now we can plug x into VRT to find the angle of WRS. So if x equals 5, well then we would substitute 5 into the angle measure, and we get that 5 times 5 equals 25. Well, if we know that this angle is equal to 25 degrees, that is angle VRT, and we know that it's a vertical angle to WRS, well then we also know that WRS is also equal to 45 degrees because those two are vertical angles or opposite angles, and opposite and vertical angles are congruent, which means that our answer is C. Now let's look at our final lesson, complementary and supplementary angles. Let's look at the first diagram. This diagram states the line JM intersects line GK at point N. So what is that telling us? Well, line JM intersects line GK at point N. Well, what statements can we identify that are true about this figure above? We're selecting two options. Well, the first statement states that G and J is complementary to G and K. What do we know about complementary angles? We know that they're equivalent to 90 degrees. That means if you add those two angles together, you should get 90 degrees. Well, G and J is actually a 90-degree angle on its own. How do we know that? Well, because G and J and K both share that line, making them a linear pair. We know that linear pairs equal to 90 degrees. If this is equal to 90 degrees, well then, if we add angle G and J, 180, subtract 90 from both sides, we would get that G and J is equal to 90 degrees. Therefore, those two cannot be complementary because G and J is already complementary on its own, or equivalent to 90 degrees on its own. Let's look at the next one. The next question states that M and L is complementary to K and J. Well, here we have M and L. And here we have K and J. Right? Well, those two angles are in fact complementary to each other. How do we know that? Well, once again, we see here a linear pair. J and K and M are a linear pair because they share that line. We know that J and K is equal to 90 degrees. So we take 100 degrees equals 90 plus K and M. Oops. Subtract 90 from both sides. We get that K and M is equal to 90 degrees. So this entire angle is equal to 90 degrees. So if we are being asked if the angle M and L and angle K and L are complementary, that is in fact true because if you add those two angles together, you should get 90 degrees. Let's look at the next statement. The next statement states that M and G is complementary to G and J. What do we know about complementary angles? Well, they are equal to 90 degrees. So let's identify these angles. We have M and G and G and J. Well, those two angles are a linear pair. We know that linear pairs are equal to 180 degrees, which means they are not complementary angles, but they are actually supplementary angles, which means that we can mark the statement off. Let's look at the next one. The next statement states that K and J is supplementary to M and L. Let us remember that supplementary angles are equal to 180 degrees. So let's see if those two angles are equal to 180 degrees. Well, let's identify K and J. And let's identify M and L. Well, it looks like those would be equal to 90 degrees, but we are missing this space. Therefore, if we added those two angles together, they would not equal 180 degrees. Let's look at the next one. The next statement states that G and M and J and K are equal to 180 degrees. Well, we know that J and K is in fact equal to 90 degrees. We know that J and K is an opposite angle or vertical angle to G and M, which means they are congruent. If you add those two angles together, 90 plus 90 equals to 180. We know that supplementary angles are two angles who, when added together, equal to 180, so that is in fact our answer. Let's look at the next problem. This problem tells us that if two parallel lines are intersected by a third line, so that angle 1 and 5 are congruent, so angle 1 and 5 are congruent, which of the statements is true about 3 and 5? Right? So which of the statements is true about 3 and 5? Well, what this tells us is that 3 and 5 are actually, well, let's look at 1 and 2. Those two angles are linear pairs. They would equal to 180 degrees. 5 and 6 are linear pairs. They would equal to 180 degrees, right? We know that 3 and 2 are our vertical angles, which means that this angle with 6 would be a vertical angle. We know that 1 and 4 are vertical angles, and 5 and this angle would be vertical angles. So what does that tell us about angles 3 and 5? Does it tell us that they are acute? Well, not exactly. We cannot determine the measure of an angle based on the diagram, so we cannot conclude that it's actually an acute angle. Can we conclude they're congruent? Well, if 1 and 5 are congruent, well then 3 and 5 cannot be congruent. They are complementary. Well, if 1 and 5 are congruent angles, and we know that 1 and 3 in this instance share that line, making them supplementary angles. Supplementary meaning that if you add angle 1 plus angle 3, you would get 180 degrees. Well then, it's reasonable to conclude that 3 and 5 would also equal 180 degrees. Why? Well, because 1 and 5 are congruent. Actually, the easiest way for me to write that, for you to see that, is if angle 1 plus angle 3 is 180, and we know that 1 and 5 are congruent, well then we can substitute 1 for 5 because they're just the same. They're exactly congruent to each other. They're the same measure. That's what congruent means. Well then we can reasonably conclude that 5 and 3 are congruent. As you can see here, we kept the 3 where it was, but we did in fact switch 1 and 5 because 1 is congruent to 5, meaning that they are interchangeable. So this tells us that angle 3 and 5 are supplementary, meaning they are equal to 180 degrees. Let's look at the next question. This question states that angle RST is a right angle and angle RSU is equal to 25 degrees. Well, if RST is a right angle, which means it equals to 90 degrees. That's what we know about right angles. Right angles equal to 90 degrees. And we know that RSU is equal to 25 degrees. Well, that would tell us the measure of TSU. How? Well, if we know that those two angles are complementary, meaning they're equal to 90 degrees, all we'd have to do is add RSU plus TSU to get 90 degrees. We know that RSU is equal to 25. We don't know the measure of TSU just yet, but we do know that they will equal to 90 degrees. Subtract 25 from both sides, and that gives us that TSU is equal to 65 degrees. Next question. I am also going to skip over this last problem, as you will not see a problem that represents this problem on your Unit 1 exam.